So hello everyone. Today we'll be doing the second case of memory management, which is a part of operating system and first fit. For first fit, we initialize the process, allocates the process to a memory block, which is having the value greatest of all the memory processes. Memory blocks so that the internal fragmentation is the maximum. What is internal fragmentation? When we define, when we find the difference between the memory allocated and the process memory, we find the leftover memory. So if that memory is the maximum one, so we call the internal fragmentation to be less the maximum one. We'll be taking the case over here. We'll be finding the difference of the memory, allocated memory, and the process, and we'll be using the leftover memory for reinitializing or reallocating to another process as well. So first of all, we have done the code in C++. We have hard coded the values of memory block here, and we have find the length of this memory block array uh, with the help of size of function, size of the memory block divided by size of the memory, each memory block, which is size of the memory block at the 0th index. You could take any index because the size is same only for an array. For we have hard coded the value of the other process in an array, and we have find the length of the array in the similar fashion. We have taken a third array. We have dynamically initialized it and with the value -1 using a for loop. Now this is the main code. For this, we'll entirely loop through the process because we have to find for which process the memory allocation is the worst one. So for the worst index is initialized with -1 every time the process changes. So for the first process, the worst index is -1. It will go and loop through the entire memory block. So for j is equals to 1 till n, which initialized with the length of the array. If the memory block is having the size greater than that of the process. So first of all, we have to find whether the process is being able to fit in that memory block or not. So this if condition is for that. Now, if that satisfies, it will again go down. It will check if the first index is -1 or the second condition, which I will shortly discuss. So for the first time, or for the first process, every time when the process changes, we initialize the worst index to be -1. So for the first time, worst index is -1, so it comes down and it checks for what index it was satisfying the condition over here, and it was satisfying the condition like 212. It satisfied the condition was first time was for 500. So the worst index is changed to 1 for 500 for the process 212. As the first process we have taken 212, it comes down. The worst index is -1, it comes down, checks for 0th memory block, which is 100. If 100 is less greater than that of the process I 212, no, it is not. Again, J increments and checks for 500. So it's satisfied for 500. That's why I'm saying so. It comes down, it checks for the first time what worst index is -1. Yes, it is. So it comes down. Worst index is being changed to J, which is 1 for 500. Then again it loops further. It goes, checks for 200. No, it does not satisfy the condition for 300. Yes, it does. But now we have to check if it does, it comes down. We have to check the worst index is -1. No, it is not because we have changed it to 1 because 500 satisfied the condition. Now we'll check for this condition, whether this satisfies the memory block at J is greater than that of the memory block at the worst index. So worst index, it was 500 and the memory block we are talking now is 300. So 300 is not greater than 500, so it does not satisfy, and the worst index remains to be 500. Now it further loops and checks for 600. So 600 satisfies the condition. It's greater than that of the process 212. It comes down. Worst index is not -1. Checks for the other condition. So 600 is greater than that of the worst index memory block, which was 500. So 600 is greater, so it comes down. The worst index is changed to uh, the value of 4, 600. This 600 is at the index 4 because it's 0, 1, 2, 3, and 4. So now no more memory block is to be checked. The entire array is being traversed. It comes down. The worst index is not -1. Yes, it is not. It is now 4. For the process 212, we found the worst memory block uh, for 212 to be 600. So allocation at I for the ith process, 0th process, it is allocated to the worst index, which is that of the value 4. So the process, this is done for printing. Here I have shown. Let me enlarge this. So the process 212 is allocated to the memory block 600 and the memory left is 388. Now this 388 can be reutilized. We have done the code in that fashion only. So now we'll check for another process. The other process is 417. So coming back, the I is incremented. As you can see, nothing is to be done. This is entirely done for printing only. The processing will looping through every process for this tabular form, which I'll discuss at last. So I is incremented for the process now 417. It goes and checks the entire memory. Now remember the 600 is being replaced with the 388, where I will show you this memory block at worst index is initialized with memory block at that particular worst index minus the process. Now it is being replaced with the value of 380. So yes, now it will check 417. 100 does not satisfy. It is lesser than that. This first condition is we have to check the memory block is greater than process or not, and then it will check whether the memory block is uh, the worst suited for the that particular process or not. So 500 it satisfies, fine. It goes further. 200 it does not satisfy. 417 is not smaller. It goes to 300. It does not satisfy for 47. Now this is 388 only. So 417 does not satisfy. So it will only work for one case, and that will be the case of 500. So 417 is allocated to the block number 2, which is 500. And I have shown 417 is allocated to the memory block 500. The memory left is now 83. So 500 will be replaced with the 83 value. Now it will check for 112. This is 100. It does not satisfy. Memory block at J is not greater than 112 is not 100 is not greater than 112. So it does not come down. Checks for the value at 500 is now replaced with 83. Does not satisfy. 112 is greater than 83. So does not satisfy. We have to find the memory block to be greater than the process. So it goes to 200. Okay, it satisfies because 112 is now smaller than that of 200 case. It goes further. This memory block at 300, it does satisfy because 300 is greater than 112. Then the value is being replaced. Earlier it was initialized the worst index with the value at 2 for 200. Now it will again check for the next one, which is 300. If the memory block 300 is in that of the process 112, yes, it is. It checks that the worst index is not -1, it was changed. If checks that now the value, which is 300, is 300 greater than that of the earlier value, which was initialized with the worst index. Yes, 200. It is great. 300 is greater than 200. So the worst index is changed to the value of 3 for 300. Now it again loops through. This is now 388 as we had previously replaced the value. It is being allocated already to the process number 1, as you can see, and the remaining value was 388. So yes, it satisfies 112 is greater than that of 112 is lesser than that of 388. So it comes down, it checks worst index is not -1. Is the memory block at J is 388 greater than the memory earlier memory block, which was 300. So yes, it is. So memory index is changed, and the value of 388, which is at the memory block, fifth block only, is being. So here you can see easily in the tabular in this table that we can allocate the block again if it is the worst suited for that particular process. So if 112 is allocated to the memory block 388, the memory left is 276. Now remember, this is 100. 500 value was replaced with 83. 200 value is not changed at all. It was not allocated to any other process. 300 value also remains 300. And this one is last one, 600. It is it was changed with 388, and further 388 was being again used, and now it is 276. So 426 is not at all satisfied with any of the memory blocks, so it is not allocated any memory block. And here I have written the condition. If the allocation is not -1, then we'll be using this. And if it is -1 only, because we had allocated the entire array with -1 value, so later on, if it is not initialized or allocated to any of the memory block, then it remains -1. So yes, uh, now the entire thing is being done. The tabular form shows here the entire worst fit algorithm. Thank you so much.